So let's start this episode by reviewing how we bring in data from a spreadsheet into a Jupyter Notebook environment. The first thing we need to do is import the Pandas library. Pandas is our database library that's going to read in the data from the spreadsheet and then work with it, kind of store that data for us in the Python environment. We need to import the matplotlib pyplot library so that we can create graphs of all the wonderful data that we're working with. And then we use the pd.read_excel command. This is really the key to making this whole process work, because this is the function that will take the information from the spreadsheet and bring it into the Python environment. And we're going to work with a different example this time than last time. Last time had lots and lots of data, but only 2 columns. Now we've got less data, but more columns. This is data like you might see in an introductory or high school level experiment. We have a cart going down a ramp. It is, I believe, getting slower. Oh, no, that's right. There's a cart on a ramp. It gets sent up the ramp and then comes back down. I recorded this, I believe, using a motion sensor. It's one of those sonic motion sensors that can tell the position, then uses position to calculate velocity, uses velocity to calculate acceleration. I'm guessing there's something else going on here. If it's got equal number of data points for velocity acceleration, I might have truncated some parts of this data now that I think about it. But anyway, this is the type of thing you probably already have your students using in Excel, right? They can graph position versus time, velocity versus time, acceleration versus time, and they can see how those 3 things are related to each other in terms of slope or area under the curve. But there's a lot more we can do in the Python environment. And so in order to do that, we're going to import it. And remember, the key to importing is just trade out this unique key here. So wherever you upload your data to Google Sheets, you're going to grab this key here. This is the thing that uniquely identifies your Google Sheet. You're going to copy it, come in here, and paste it over this key here in the function, and that will access your specific Google Sheet. You're welcome to work with mine. Mine is set to be viewable by anybody, so you're welcome to start with mine, but then if you want to use your own, that's a good opportunity to really learn this system. And then we're going to make 3 graphs here. Let me go and click run so this will start up in the background. We're going to make a plot, a scatter plot specifically, of time, position, time, velocity, and time, acceleration. And those create pretty much exactly what you would expect: a position versus time graph, a velocity versus time graph, and an acceleration versus time graph. And we saw last time how you could change some of the settings here. We talked about how to change those axis labels to include the units. I really should just have the units in here because then they'll get read in directly. But we also saw how you can zoom in and zoom out using those xlim and ylim commands. So like right now my acceleration looks very messy. But if I wanted to change that, right, it's zoomed in very far. So I could change this ylim to go farther out. Maybe I want to compare everything, in terms of compare it with 0 acceleration. So let's go 0 to, what's our current minimum? It looks like it's about negative 1.08. Let's call it 1.1. Actually, we'll find out exactly what the minimum is in a second. I'll show you how. That changes this most recent graph. So anytime you just use the PLT command, you're referring to the most recent graph. So if I wanted to change the ylim of one of these others, I'd have to insert a new line and then start writing commands there. But I've got my position versus time, nice concave down parabola. My velocity versus time, a nice, pretty steady line of negative slope. And I've got my acceleration, which exhibits a pretty interesting change right around the time that the cart stops going up the ramp and starts going down the ramp, right? That's how you can tell that there's some air resistance at work, because on the way up, gravity and air resistance work together. On the way down, gravity and air resistance work opposite of each other, which is pretty cool. Okay, let's suppose you now want to get some statistics from your data. Like, let's suppose you are interested in the average value of that acceleration, right? Let's ignore the fact that there's a change right here, just for the moment. I'll show you how to handle that change in just a second. Let's suppose you want to get the average value of the acceleration, right? Average position, average velocity is, I don't think you would typically do that. Typically you do average of a thing you expect to be constant. I think if you're doing that lab differently and average of this velocity gives you some useful information, please tell me. I would love to hear. But let's suppose you want to get the average of this acceleration. Well, there's a lot of statistics functions built into NumPy. So NumPy is another library, stands for Numerical Python. Pretty much in all these labs, you're going to be importing Pandas, Matplotlib, and NumPy. You can just train your students to always put that at the beginning, or just always have it at the beginning of the template that you give your students. And these import 99% of the functions that you're going to need in an introductory setting. More advanced things, there's SciPy, there's SimPy, there's all this other wonderful stuff, but usually those three are the ones that you need. NumPy's standard abbreviation is NP, Numerical Python. And what we're going to do, we're going to use NP's average function. So remember, the thing this dot signifies is a possessive. It's saying somewhere in the NP library, there exists a function called average that can take in a whole slew of numbers and then calculate their average, right? So remember, whenever you access database of acceleration, right, that's the name of this acceleration column up here, that database of acceleration is accessing all these numbers. It's saying, I want that whole slew of numbers in a list. I want to get that entire range of values there. It's not a singular value. It's a whole range of values. It's a whole table of values, basically. So then we say, okay, I want you to take those values and I want you to calculate their average using NP's average function. So let's click run on this, see what we get. I get a negative 1.03. That looks reasonable. Let's check it in Google Sheets. Their average is, yep, negative 1.03. So you end up with, good, we've confirmed the answer there. But let's suppose I only wanted to get the average of that first range, right? So let's suppose I want to find out where that time equals 0.4 happens. Excuse me, I should look at where the maximum happens. Happens right between 0.3 and 0.4. So let's find out where that happens. So let's see, this is going to be spot 0, 1, 2, 3, 4, 5, 6, 7, right? So if I want to get the average of just those first 0 through 7, remember I can access a slice, a subset of the data by using the colon, right? So I can say 0:8, run the code again, and I can get a slightly stronger average, negative 1.06. So it's a little bit stronger acceleration there. All right, now let's try 8 through the rest of the way. Let's try 8 through. Oh, I forgot to count what the total number was. And actually, I don't need it. If you just leave a colon and no number, it will go to the very end. Let me show you. And now what I get is the average of that first half of the data set and then the average for the second half of the data set. And so now I'm immediately able to tell that, yeah, there's a pretty different acceleration from the first half to the second half. Well, I say it's pretty different, right? I have no idea what the error bar is on this. I need to get the standard deviation. Well, that's what np.std is. So let's copy and paste these. Copy, paste. Now instead of average, I want standard deviation, std, standard deviation, std. Let's click on play here. And here I get my standard deviation values. Now I'm quickly getting a wall of numbers I don't recognize, so this is where it's useful to print things. So let's get those average acceleration before on the way up and on the way down. Ascending and descending, I suppose, would be the proper way to say that. Copy and paste. And now let's get acceleration, standard deviation, ascending and descending. There we go. Now I've got some nice labels, right? Anytime your students are printing out a slew of numbers, tell them, hey, put in a print statement so we remember what these things are when we're looking over this, right? And so now the students could start to work with this math a little bit, right? They could start to evaluate whether these two are actually significantly different or whether those error bars are overlapping between the two averages. I could also use the max and the min function. I'll let you play around with those. Those do basically what you would expect. They give you a maximum value and a minimum value. And then there's more exercises for you to do here about, well, how would you calculate the ratio of the two? Like, how would you use this slash here, right? In order to divide something, you would just use a slash there, which is pretty cool. But now let's suppose you want to generate some new data, right? Because we have the position versus time. We might not necessarily be interested in the position. Maybe we're interested in the displacement. Well, what you can do in order to get this, you can start doing math on the items in the database. So let's suppose I want to take database of position and I want to subtract off the initial value. Well, let's go over to the initial value. It's a 0.039. So what I can do is just ask it to take database of position minus 0.039. Now Python is pretty reasonable when it comes to lists, right? So this is an entire list or array of numbers, right? It's a whole slew of numbers. It's that entire column. When it sees column minus a pure number, a scalar there, it's going to interpret that as intelligently as it can. It's going to assume that you meant take 0.039 and subtract it off from each of these values, right? Which is pretty cool, right? It's pretty neat that it can interpret it that way. So it's going to take database of position, subtract it there. Now that's a wonderful calculation. It will do that in the background and then immediately forget it. We have to save that information somewhere. We have to store a new variable called displacement. So the way we're going to do that, we're going to add a column to the database called displacement. Now there's currently no displacement, right? If you go over to here, there's no column called displacement. We can even test that here. Let's add a code here. Let's ask it, first let's grab this, Control C to copy. We'll do print, there we go, print this displacement. It has no idea what the displacement is, right? It has not been defined yet. No one's told it what displacement is. What this is doing is it says, hey, I want you to create something called displacement. I want you to create a column called displacement and set that equal to the result for this. And then we'll have it print the displacement afterwards. And now watch this. And now it's able to print it because now it knows what it is. Before it did not know what it was because it didn't exist yet. Here we defined it. We said let displacement be this, and then displacement is that thing. And if you look at this, you can go in and check the numbers if you want, but basically it's each of these numbers downshifted by that 0.039. So of course the first one is going to be 0, the next is going to be pretty small, the next one will be a little bit bigger, etc. We even get to some negatives there at the end because these two are actually less than 0.039 because it went a little farther down the ramp than it had started at, right? And so that's kind of cool because now you can take this, you can calculate anything you want with it, right? So here what I'm asking you to do to try this out, I want you to calculate the kinetic energy, right? Because you have the velocity, right? You've got the velocity up here. You can get the kinetic energy by squaring that thing. And so I walk you through how to do that, how to calculate the square here. One thing you just want to note is that Python takes a power, instead of a caret, it's a double asterisk, just some historic reasons why it does that. It's just the way it is there. And then you can make a database column called kinetic energy. But of course you can do the same thing with potential energy, right? So you can calculate the height by getting np.sine of the angle, right? Because what you have in the position is the position up the ramp. But if you multiply that by the sine of the angle that it makes, then you can get that as just the height